talk about acid-base disturbances. We've been already talking about regulating acid-base. With two major organs regulating this is going to be the lungs and the kidneys. Now, as you've been seeing, if there's something wrong with this reaction that we're utilizing, the lungs will actually compensate if the kidneys are not taking over or not doing its job, and the kidneys will take over if the lungs aren't doing its job properly. So these two organs are going to balance this whole acid-base balance. But now let's talk about the acid-base disturbances. In other words, if we understand the acid-base or this reaction, then what happens when things go wrong? So I'm going to put it up here because you just, how many times pretty important. We'll be utilizing this. Are you getting sick of this reaction? All right, it's all over the place. Okay, so let's talk about acid-base disturbances. Now, before we get into the details, let's just talk about how do we call these certain things. First off, you like my little joke up here, you're a 10 on a pH scale, maybe because you're basic. That's something you could actually talk to people and your friends and family. They don't know what the heck you're talking about, right? All right. So acid-base disturbances. Basically, 7.4 is our magic number of what our pH should be in our blood. Anything less than that is going to be acidic. Anything more than that is going to be basic. And if it goes below below 6.8, it's a very tight window. 6.8 from 7.4 sounds like not much of a change. But if anything less than that or greater than 8.0, things will become fatal. Okay? It's just the acidity is going to change the enzymes that are happening in your blood or the hormones in your blood. Things will start changing and you can't function. Can you imagine if ADH wasn't working, that the acidity is going to destroy that, or a certain another kind of hormone, or let's say angiotensinogen is not working, right? So it cuts this off. So this acid-base disturbance is quite vital for you to understand. All right. So it's just showing you here. Here's 7.4. If the pH drops, so you have accumulated. Let me just do it this way. So you have accumulation of acids. All right, hydrogens, or a loss of bases, either one. Think about this. If you have, let's just look at this over here. This is an acid, this is a base. So if you increase this, then it's going to be acidic, right? Out of the combination of the solution. If you decrease the bicarb, then net-wise, you haven't touched this, but net-wise, there's still more of these. Does that make sense? That's the way you got to be looking at this. All right? So whether you have a loss of bases or an addition of acids, that's going to increase the concentration of hydrogens. If you increase the concentration of hydrogens, your pH will go down. That's the only oddity you got to think about, is that if you increase hydrogens, pH goes down. I know? All right. So it's one of those things that I'll probably go up. If I go up the head, I got to figure out why did you do that? Shouldn't the pH go up if hydrogens go up? But that's the only thing that you do have to be aware of. And we've been talking about that, but that's a very careless mistake that a lot of students make. Well, if hydrogens goes up, the pH goes up. No. Hydrogens go up, the pH goes down. Okay? Likewise, if we lose acids, if we lose hydrogens, or if we increase our bicarb or any kind of base, then that's going to be net-wise, whether you decrease this or you increase this, you're going to have a decrease of hydrogens. If you have a decrease of hydrogens, then the pH is going to go up. Does that make sense? All right? So the decrease of concentration of hydrogens, then the pH is going to go up. If it goes down, if the pH goes down, we say that's acidosis. If it goes up, then it's alkalosis, like alkaline. Okay? You could say acidic or you could say basic. That too. All right? Acidic acidosis, alkaline or basic or alkalosis, all meaning the same thing. Okay? So we can classify this by cause. What's making that acidosis, making that become acidotic? It could be a respiratory reason. If you increase the CO2, you just can't blow it off, the CO2 is going to go this way and you're going to make a lot more hydrogen. See? Or if there's another non-respiratory reason that's causing this, then we could call it metabolic. Okay? We also have the blood pH. If the pH is low, then it's acidic. If it's high, it's alkaline or basic. So then we put these things together. You could have respiratory acidosis, respiratory alkalosis. If it's due to a respiratory reason. If it's due to some other reason than respiratory, then we call it metabolic. Metabolic acidosis, metabolic alkalosis. Okay? So acidosis, you can say respiratory acidosis, it's an increase of hydrogens that are due to some sort of respiratory generation of those hydrogens. I.e., you increase the carbon dioxide, is going to make more hydrogens over here. You also have metabolic acidosis, and that's an increase of hydrogens due to some other non-respiratory reason. We could decrease the amount of this, that makes more of these net-wise. You see what I'm saying? Respiratory didn't cause that, some other means did. If we decrease the pH, your nervous system gets depressed, slower. That can lead to a coma, and that can cause death. Okay? So we don't want it to become acidotic. We also have alkalosis. We have respiratory alkalosis, where we're going to decrease the hydrogens due to some sort of respiratory reason. A decrease of carbon dioxide is a good example of that. And we also have metabolic alkalosis. Something's making the hydrogens go down due to some other non-respiratory reason. We can increase bicarb. If there's something that's going to make the bicarbonate go up, we haven't touched this, but there's more of this than this, therefore we're going to have less. And that'll be alkalosis. So these are 4 disturbances. And now we're going to go into details about each one. Okay? With alkalosis, just want to tell you, if the pH goes up, the nervous system does the opposite. It actually gets more excited. That can cause tetany, which means it'll go into convulsions. When you have too much convulsions, you can't breathe. There's basically, let's say your neck muscles start getting convulsed, you can't get air in because you're suffocating, and you could die from that. So let's talk about each one of these now. Respiratory acidosis. And we've been talking about this, but now we're putting it all together with other ones. For some reason, you're going to have an increase of carbon dioxide. It could be due to emphysema. COPD is chronic obstructive pulmonary disease, which basically is going to be emphysema and chronic bronchitis. Not bronchitis that you can get from an infection causing bronchitis, like pneumonia of some sort. Chronic bronchitis is something where you're being constantly exposed to something that's going to irritate your bronchioles. Smog in Los Angeles, Smoking. When you smoke, that smoke is going to irritate the lining of your bronchioles and bronchi. All right? If you're in a room with a lot of smoke, you've been doing secondhand smoking, that's going to irritate that. Does that make sense? So chronic bronchitis is that your long-standing exposure to something that's going to irritate your bronchioles. Okay? And that's what COPD is. And also hypothyroidism would cause this too. Okay? But I like to use the one highlighted here. That's an easy one for you to actually understand because we've been talking about that. And what happens here is that normally you could blow off your CO2 . That's what you normally do, but something's going to block it. Emphysema. You have problems exhaling. So if you can't exhale, then this carbon dioxide will go up. Reaction goes this way. You're going to make a lot more hydrogens. So what does, if the lungs are causing that, that's what we call respiratory acidosis, then the kidneys are going to compensate. It's going to reabsorb bicarb to put more bicarb back into your blood system to not touch this, but you'll have more of this than this. And net-wise, you will have less of this. The kidneys will compensate this. So what happens here with emphysema, you have a decrease of respiratory function, meaning that you can't blow out the CO2. You have hypoventilation, which means that your carbon dioxide is going to increase, which means that you're going to increase these items over here. So the compensation is the kidneys. The kidneys are going to compensate to get rid of, or actually do something to these water-soluble electrolytes. They're going to reabsorb bicarb, and it's also going to secrete hydrogens. Does that make sense? You're going to lose some of these for the kidneys, but you're going to accumulate and reabsorb these over here. You're going to create a more alkaline situation to correct it. Does that make sense? Okay? Questions about respiratory acidosis? And there's the wonderful reaction. All right. Let's talk about this one. Metabolic acidosis. So this is acidosis due to some other non-respiratory reason. So it's due to what we call fixed acids. Acids from anywhere except the lungs. That's basically what fixed acids are. There's a few things that could be causing this. DKA, we talked about that, go back. And this is a good example that I want you to do. If you don't know what DKA is, go back to when we talked about diabetes, the endocrinology. I know that's not a very favorite subject for many of you, but the final exam is coming up. Start studying for the final exam now, because these things can pop up for that. In a nutshell, what happens here is that since glucose in diabetic mellitus, not insipidus. Diabetic mellitus, they can't get the glucose to get into their blood system, or I'm sorry, into their tissues. So their bodies start to break down fats. Since they can't use glucose because the insulin can't work, now they start breaking down fats. And one of the byproducts of fat metabolism is going to be what we call ketone bodies, or also known as ketoacids. So they start accumulating acids in their bloodstream from the breaking down the fats. So this acid is going into the bloodstream, the hydrogens are going to the bloodstream, and it's due to some sort of non-respiratory reason, and that's why we call it metabolic acidosis. Lactic acid, an increase of hydrochloric acid, diarrhea will also do this. Aspirin, another word for aspirin is acetylsalicylic acid. Someone's taking a big overdose on aspirin, that's what will happen. Also, if you have kidney failure, you're not going to be able to pee out hydrogens. They're not going to work. So then the hydrogens stay in the blood system. Okay? So when you have this kind of situation, it's due to some non-respiratory reason. The kidneys, there's something going on with the kidneys. So therefore, the lungs are going to compensate. Your products are increasing over here, so the reaction wants to go this way, and you're going to build up CO2. Therefore, your lungs are going to blow off CO2 to get it out. So, what happens here in DKA, diabetic ketoacidosis? They increase the keto acids from fat metabolism I just explained to you. That means we're going to have more hydrogens in the blood than we do as bicarb. So therefore, you're going to have a net decrease in bicarb. Does that make sense? Right? So what happens is that the lungs are going to compensate. You're putting more products over here. The reaction goes this way. You're going to make more CO2, and the lungs are going to blow up all that CO2 to get it out of the system. Does that make sense? Yes? You don't understand it? Look. If you're increasing hydrogens, so we go back to this. Normally it's supposed to be 50-50, right? But we're creating more hydrogens from elsewhere. They're coming in from someplace else. Not the bicarb, the hydrogens. These keto acids. All right? You understand that's what's happening. So we're going to be increasing the hydrogens here, which means that we're going to have more hydrogens than bicarb. Altogether, you're going to have more of this. Okay? But because we have more hydrogens, this is going to make the pH go up or down? Down. We need to get rid of these. So the reaction want to go, so you have basically, not this, you now have 70 numbers, which means compared to that, this is 30. Right? These increase. Does the reaction want to go that way or that way? That way. So the reaction is going to go this way, which means are we going to increase the amount of carbon dioxide or decrease it? Increase it. So you're going to have a whole mess full of CO2. Now keep in mind, this is always going to be happening until we can fix this. So it's always going this way, which means we're always going to be building up the CO2. But we've got to get rid of the CO2 because they're getting too high. How do you get rid of carbon dioxide gas? Breathe it. The lungs are going to take over this. We need to breathe out all this stuff. For your body to do this, would you expect the person to hypoventilate or hyperventilate? Hyperventilate. You're going to blow this all off. And they have a very specific, the people who have DKA have a very distinct way of breathing. We call it Kussmaul's breathing. It's what it is that it's a deep, rapid labor. It's like this. And you can see it. They're usually comatose because they go into this DKA incident and this crisis, and they're usually lying on the ground and they're unconscious, and their breathing is classic. It's deep, it's rapid, And you see that it's not like smooth, it's labor. He's really working to do that, but he's unconscious. The other thing is that if you go up to the person and see what's going on, you could smell his breath. The breath with ketone bodies is very distinct. Has anyone smelled that before, anyone? Or heard about it? It smells like acetone, nail polish remover, and grape juice. It's a very distinct smell. And if you're working in a hospital and you know someone who has that upstairs, just go over there. Once you smell it, you won't ever forget it. And it may save your life, or at least someone's life. You go up there and you smell this. You know it's not, someone's unconscious and you smell that, you know it's not the heart. You know that that person's a diabetic. You see what I'm saying? That's a very distinct smell, okay? So when you hyperventilate, now the amount of carbon dioxide goes down, and it should try to compensate. Will it ever compensate? No, because this thing keeps on going up. Until you can stop the keto acids, yeah, then it'll stop. But this will always go up, which means the reaction's always going this way. So it has to be corrected. But your lungs will try to compensate. Is that clear? Is that clear? All right? Now, there's something that's also going to be helpful, and I'm not going to test you on this. I'm really not going to spend much time on it either. But this is something that I know in other courses they're going to expand on. And this is where we were just talking about in terms of what the metabolic acidosis. There's a lot of reasons why someone would have that. This would determine it. It's something called the anion gap. Okay? So I'm not going to go into details. You don't have to memorize this or the formula. But basically what it is the difference between measured cations and anions. Right? Cations are positive charge ions and anions are negative charge. So basically we subtract anions from cations. And these are the ones they usually use: bicarb, chloride, sodium, potassium. When you put the numbers in there, if they're given, you get this number as between 8 to 16 milliequivalents per liter. There's always this, what we call anion gap. There's some sort of difference between the two in some of the cases. So if you know this person has metabolic acidosis and they have an anion gap, that's going to limit, that's going to help you diagnose the reason for this. All right? Proteins and anions are not measured. This is why there's a normal anion gap of this amount of area over here. Okay? So what happens here is, they're trying to show you where the anion gap is. There's sodium over here, and you have chloride and bicarb. There's this gap. And that's why we have that. So basically what it is that if you know that there's metabolic acidosis, and you calculate there's an anion gap, then it's going to be due to these reasons over here. So I have a little mnemonic here as mud piles. If they have metabolic acidosis without this anion gap, then it's going to be one of these two reasons. A GI reason, whether diarrhea or hydrochloric acid, an increase of it. Okay? Questions about